Alright, so in the next few videos, we'll be looking at examples that where we can apply the shoelace method in problems involving the area of either a triangle or perhaps a quadrilateral or maybe even a polygon. Alright, so let's take a look at example 11 first. Okay, so in example 11, they give you a triangle with three vertices, A 1, 3, B 5, 1, and C 3, R. Now you realize from the start of the thing already, okay, the fact that we have an R over here, an unknown, it's quite impossible from these three vertices alone to know uh, what's the anti-clockwise direction. All right, so yeah, so we won't know which direction it is. Okay, that's why we need to read on, and perhaps the question will give us more information in the next few lines. All right, so now the question gives you the if the area of the is 4 square units. So now we have the area is 4 square units. Okay, and then they tell you, okay, find the value of R if A, B, and C are in an anti-clockwise direction. So now we know for a fact that if I draw our triangle for part A, okay, my A, B, and C will go from here. Next one will be B, and next one will be C. Okay, so what we can do is we can use the shoelace method, okay, and put R in the shoelace method, and from there we can solve for R. So let's just quickly do up the shoelace method. Okay, so if A, B, and C are in anti-clockwise direction, we will have half. Okay, so let's choose A as our starting point. So A will be 1 3, B will be 5 1, C will be 3R, and we will go back to A, which is 1 3. Okay, and you get equals to, and the area is given as 4 square units, so just put equals to 4. So what we need to do now is to expand this. If we go back to our notes, okay, we need to expand it into this particular form, x1 y2 plus x2 y3 plus x1 x3 y1. So it will be very helpful that we do this step by step. Okay, so let's write down half first. Okay, so we write down half first. Okay, and then we'll start doing all the additions first. So 1 times 1, 5 times r, and 3 times 3. So we will have 1 times 1, which is 1, plus 5 times r, which is 5r, and 3 times 3, which is 9. And then we'll do all the subtractions. So we'll do this, this, and this. So we'll have 5 times 3, so minus 15, 3 times 1, minus 3, and r times 1 minus r. Okay, and from here it becomes a simple linear equation that we need to solve. Okay, so we can just multiply by 2 throughout, so we can get rid of the half over here, and we can simplify whatever that's inside here. So 1 plus 9 is 10, minus 15, so negative 5, and minus 3, so negative 8. So we have minus 8, and 5r minus r is 4r. So 4r minus 8 is equals to 8. Okay, and we can just proceed to solve for r. So for r equals to 16, r equals to 4. Okay, so the tip is, or rather the thing that we need to note is which is in the anti-clockwise direction. Okay, now if you look at part B gives you a similar question, except that instead of A, B, C, okay, instead of having A, B, C, now we have A, C, B. So we should change this to C, and we should change this to B. Okay, so we know for a fact that we have to go from A to C to B. Okay, it doesn't matter whether or not we choose A as a starting point or C as a starting point. Later on I will show you another example where we use point C as a starting point instead. So again, same thing, we will just put in, we'll choose A as a starting point first, so half. So A is 1 3, C is 3R, B is 5 1, and then we go back to our starting point, which is A. Okay, so we must go back to our starting point, which is A, which is 1 3. Again is equals to 4 square units. Okay, so same thing, we need to change it into this linear form. Okay, so do the positive first. Okay, so we have do the addition first, half bracket. So let's do the addition. We have 1 times r, 3 times 1, 5 times 3. So we have 1 times r, which is r, plus 3 times 1, which is 3, plus 5 times 3, which is 15. And then we need to subtract all the other diagonals. So 3 times 3, 5 times r, 1 times 1, all these we need to subtract. So minus of 9, minus of 5r, and minus of 1 times 1, which is 1. Okay, and then we get a simple linear equation again, and just quickly solve it. We will have r uh 3 plus 15 minus 9, so 15 plus 3 is 18, minus 9, 9 minus 1, 8, so we have plus 8. So we have 8, let's not put a bracket, so we have 8 um r minus 5r, so we have minus 4r over here, which is equals to 8. Okay, and then we just need to solve this. You realize that if I subtract 8 from both sides, I'll have negative 4r equals to 0 and r equals to 0 for part B. All right, so important thing is basically how you put it into the shoelace form. So the first thing, how we put it in the shoelace form, and then how we expand this shoelace form into this particular form over here, the linear form. Okay, so if you can do this and you can do this, okay, I can guarantee you can solve any questions with regards to area of quadrilaterals, or triangles, or even polygons. Okay, now let's say if I don't choose A as my starting point. So over here I choose A, I went to C, I went to B, and I went to A. Now what if I decide to choose C as my starting point? Okay, let's try something else. Okay, so we will have half, and let's choose C. So C is 3R. uh After C will be B. So you realize that the diagram is very helpful, because from after C I know where I need to go after C. So after C I'll go to B, which is 5 1, and then A is 1 3, and then we go back to C again, 3R equals to 4. Okay, so again we do the positive first, so half bracket. So let's do all the positive first. So 3 times 1, 5 times 3, and 1 times r. So we have 3 plus 15 plus r. Okay, and then we do all the subtraction. So minus 5 times r, so minus 5r, minus 1 times 1, so minus 1, and minus 3 times 3, which is minus 9. Okay, and then equals to 4. Okay, let's simplify this again. So multiply by 2 throughout. I have 8 on the right hand side, and on the left hand side we have 3 plus 15, which is 18, minus 1 17, minus 9 8, and we still have 8 minus 4r equals to 8, and we can still get r equals to, or negative 4r equals to 0, and r equals to 0, which is still the same answer. So it doesn't matter which is the starting point. Okay, so honestly speaking, you can start from any points. So the starting point doesn't really matter. What matters is the fact that it goes in an anti-clockwise direction. The moment you can get the direction correct, okay, and you can put it into these two forms, you're done. All right, so in the next example we will take a look at further examples of how we can find the area in now given all the points. Okay, so do move on to the next video if this is okay with you.